The UNOLS annual meeting. Again, keep in mind the meeting is going to be recorded. And as usual for Zoom meeting protocol these days, please keep your microphones muted while people are speaking. And if you have a question, use the raise hand facility in the Zoom, and somebody will call on you to ask. With that, today we have a series of facilities discussions. Doug, do you want to?
Sure enough. Thanks, Craig. Good to see everybody this afternoon. Thanks for joining us, and hopefully everybody had a good weekend. We've got 6 different presentations lined up. We'll start with the van pool. I think Kaya Johnson's first up, and I think he and Tim Deering are doing this together. So you guys can take it away.
All right, thanks, Doug, and good afternoon, everyone. My name is Kaya Johnson. I'm the Marine Superintendent for OSU Ship Operations and also the West Coast Van Pool Manager. And Tim Deering is the manager of the East Coast Van Pool, also on the call. All right, next slide. The pooled resource concept really benefits science by offering a broad range of capabilities otherwise may be cost prohibitive for individuals or users in institutions, similar to kind of a local tool rental company. You know, it's not, doesn't make a whole lot of sense to own a tractor and a wood splitter, but you can rent them when you need them and they're ready to go. Science vans are not vehicles with wheels, but specialized laboratories built to standard ISO shipping container dimensions. Next slide. These are a few types of vans that we have offered. Isotope vans, cold vans, general purpose vans, which are really just similar to a dry lab space that can be set up for special needs or unique instruments, or just to add additional space to a vessel. We also have a calibration van, wet lab vans, and clean vans. And to the right is a picture of one of our GP or general purpose vans. Next slide. And these vans are very modular and can be easily shipped anywhere worldwide. They fit onto trucks very easily. Container ships. They meet all the regulatory guidelines and they can fit on all UNOLS vessels. And they're meant to augment lab space and to add greater capabilities to vessels and meet specific science needs. For the West Coast Van Pool, that's again operated by Oregon State University, we have 8 laboratory vans. The East Coast Van Pool, operated by the University of Delaware, has 13 laboratory vans. We work collaboratively on a lot of issues, compliance issues, making sure that we have the same kind of a naming convention. When we buy new vans, we use the same contracts, the same specs, so that there's a consistent product to the user. On the right, you can see a beautiful photo of the West Coast Van Pool on a sunny day. And then down at the bottom right, we have kind of a usage graph. In busier years, we have about 500 days underway with our lab vans. For 2020, it's not quite a usual year, so our usage is significantly less, but it ranges depending on the year. Next slide. There are a couple issues we are currently working on with the van pools. One is a regulatory issue involving the Coast Guard. This is a big issue in itself, and I could likely spend an hour talking about just this, but just to kind of provide a little background on this topic, the Classification Society, ABS, or American Bureau of Shipping, has developed a guide for portable accommodation modules, otherwise known as PAMs. And the U.S. Coast Guard issued a policy letter recommending that vans be built, inspected, and operate to the ABS PAM standards, which is a change from previous standards of what our science vans were designed to and approved to. And this is likely kind of an oversight with the Coast Guard. Science is kind of a small sliver of the overall maritime industry. So this is primarily being applied to the oil and gas industry. So we did determine we need to seek clarification. The East Coast and West Coast van pools have been working together on this with a lot of help from UNOLS, from General Counsel, Doug, a whole bunch of folks reviewing this. And we have sent off a letter to the Coast Guard seeking clarification and exemption from the policy letter that I've quoted there. We'll keep the group here posted as to progress, but I think things are moving in the right direction there. Next slide. We do want your input. Having user feedback helps us have a more capable van pool to meet science needs. We're looking at upgrading a liquid scintillation counter, LSC, to the high decks. We've kind of put out a few feelers to previous users for feedback, but if anyone here in this group has specific experience, I'd love to hear about it and what their capacity needs are. The high decks unit does have a smaller capacity per day or per batch. If there's any other favorite LSCs, I'd be interested in that. And as I mentioned, any feedback is appreciated. We'd like to be ahead of the curve to meet science needs and be prepared for that. All right, next slide. Some basic contact information. Myself and we also have a new position at ship operations here. Roberta Mesa is a logistics specialist who does a lot of the coordination for the van pools. You can reach her directly with that email or go to our meeting website. Tim's info is on the right there. And do reach out to him with any questions you may have on the East Coast. Next slide. All right, that's it for me. If you have any questions for the East Coast van pool for Tim or for myself, I'd appreciate it.
Thanks for that, Kaya. Appreciate it. And you're ahead of schedule too. Wow. Any questions for Tim and or Kaya regarding vans? You guys do a great job supporting the fleet and a lot of work went into researching the issue that Kaya talked about. So appreciate all the work done by the van pool, the two van pools. They definitely take this job very serious and do a fine job of supporting science operations on our ships, with great support from the federal agencies, obviously, to make it all happen.
Eric King, you had submitted a question. Did you want to just speak, unmute yourself, and go ahead with it?
Yeah, sure, thanks. It was just a general question about the availability of using the vans to be shipped international, to be used on non-UNOLS ships to support U.S. scientists, similar to what's been done in years past, but just thinking about 2021 and the year of continuing pandemic concerns. In other words, will they be available to be shipped internationally?
That's a great question. I don't have a magic ball to look into. We hope that they will be available if there's no restrictions on shipping internationally. We'd be happy to do so. I think most of the academic fleet, at least for the first 6 months, is looking at domestic port calls only. But we are looking at the idea of, once things open up again, shipping things out. Tim, do you have any requests for international shipping in 2021?
I'm actually getting ready to ship a van to Bermuda for the program there and bring another one back, and I haven't run into any roadblocks yet.
I hope that helps, Eric.
Yeah, sure does. Thanks. I'm asking, of course, for our own organization as we're still trying to flush out what we're doing for the rest of 2021. Thanks.
And certainly,
I'll just add in, we just got the schedules for 2021 sorted out for the academic research fleet. From there, I would imagine we start looking at what the van needs are across the spectrum, then from there see what's available for supporting other science. That sound about right, Kaya and Tim?
Indeed. And always, if you have any concerns or requests, reaching out early is helpful.
Yeah, well noted. Thank you both.
Doug, I have a question.
Sure.
About the PAMs, the new regulations. Is that something we should be, how different are they? Should our new containers conform to them? If we can get the current ones grandfathered in or exempted, but is this something we should be striving to meet?
Well, and Kai certainly could jump in this because he's spent a lot more time enmeshed in this, and Tim, but the UNOLS van guidelines or requirements are actually very comprehensive and exceed what the federal requirements were prior to this anyway. And so the goal is actually to keep doing it to those, although in the letter we told the Coast Guard that any new vans, especially accommodation vans, will be built to the new standards. I capture that right, Kyle?
Well, certainly the accommodations vans will be built to the portable accommodations module standards. That's intended for space that's lived in, so it has to have a greater fire rating, more safety equipment, alarms, communication, stuff like that. And that typically involves steel construction versus aluminum to meet that standard. So it would be difficult to meet that for all science labs and maybe just not even necessary. So really the regulation issue is kind of sorting out a little bit of confusion between ABS and the Coast Guard more than we need to shift how we do things.
All right, thanks.
And part of this is aimed at making it easier for the Marine superintendents when a van is installed on board an ARF ship, and then the Coast Guard inspector wanders down there to take a look at the ship, so that they're all looking at the right reference when they're trying to decide whether it meets the Coast Guard's needs or not, and trying to really draw attention to that. So in the end, it's an easier process to put a van on a ship and as part of an onload getting ready for a science cruise. Okay, any other questions from anybody? Thanks, Kai and Tim. Appreciate that. Next up, we're going to shift to the winch pools. First up on our list is to go to Aaron at Scripps to talk about the West Coast winch pool. Aaron, it's all yours.
Good afternoon. I'm Aaron Davis. I'm here to talk about the West Coast winch pool operated by Scripps Institution of Oceanography. Next slide, please. So our mission is to provide an inventory of oceanographic winches for shared use that allows people to borrow things rather than have to buy them. We also aim to keep our inventory in good repair and in compliance with applicable standards. To modify our inventory to better serve our community. That is, if we have equipment that is old and decrepit and is not serving anybody, then we get rid of it. If we have equipment that is called for but we don't have, we aim to get it. We also provide technical support of all kinds, cable and wire rope spooling, training, maintenance on and repairs on winches, engineering, and so on. Next slide, please. How the winch pool works. Science parties and anybody else that needs to borrow a winch communicate their needs to us. We try to match their needs to what we have on hand. And those conducting NSF-funded research generally incur no cost to use our machinery, our winches. Others generally pay a day rate, kind of a rental fee that goes by the day. There is one exception though. We have a large winch that's seldom used and very expensive to deploy. That's our Dynacon 664 winch. And the user incurs all the costs to mobilize that for non-NSF research. Next slide, please. We also conduct spooling services. That is, we take wire ropes and cables off of winches, put them back on for the purpose of lubrication or changing them for a different tension member and so on. Spooling jobs, if they're done to support NSF funded projects, they're done on a first come, first served basis, and they're generally done at no cost. Most spooling jobs, we assume we're going to do a certain number of spooling jobs every year, and most of them are within our budget. However, if you have a very large project, please contact us early, and so that we can come up with the cost for that project and ask permission to do it if we need to. 6 to 12 months in advance is ideal. Non-NSF funded projects will incur the cost of spooling. If you know what that cost is going to be, if you want to know what that cost is going to be, contact us for an estimate. Next slide, please. Who we are, the winch pool manager is our port captain, Captain Eric Buck, and I am Aaron Davis, the engineer. We also employ Lorenzo McCoy, who is our senior technician. He does a lot of our spooling work, and we deploy him with our more complicated systems to help set them up on ships. Next slide, please. Funding. All our logistics, we estimate them annual and include them in our proposal to NSF. Our engineering services, my salary is funded by our grant from NSF. So if you have an engineering project for NSF funded research, I can do it for you at no cost. Major repairs and capital equipment purchases for the pool, we request funds for those in separate proposals. And the maintenance on our equipment is covered by the day rates I mentioned earlier. Next slide, please. Our inventory, this is what we have to offer. We have 2 light duty winches, and I'll show you photographs and some more specifics in a moment. 4 mooring spoolers, TSC mooring spoolers. We have 1 new mooring winch, a Dynacon spooling winch, 1 Libis mooring capstan, a Dynacon traction winch, a Markey tensioning spooler, 3 line tensioners, and some fiber optic slip rings. Next slide, please. So this is our what we have to offer as far as light duty winches are concerned. That's the Hubble SPR 2036 winch. It's roughly the size of one of our old CMAC winches, about 5 feet on the side. It has a line extent and tension meter, and it can pull 3,500 pounds or hold 3,000 meters of 322 cable. Next slide. These are our TSC mooring spoolers, not winches. What we mean by that is these are not built to be as robust as an oceanographic winch, so we only allow them to be used for light duty winching, which is most frequently putting mooring components onto the surface of the water or taking them back off. We can't do anchor first deployments and whatnot with these. We have a new winch that's specifically for that. They provide up to 7,500 pounds of pull. Next slide, please. This is our first proper mooring winch we got last year. It provides up to 10,000 pounds of pull, withstands up to 20,000, which allows you to winch up a 10,000 pound buoy, say, in calm seas without exceeding its capacity. It also has tension scope and display and holds 2,800 meters of 1-inch line, which is actually larger than we could actually use on this, but that's just an idea of how much it holds. It's the same as a TSC spooler. Its footprint is about the same as well. Next slide, please. This is another mooring spooler we have. This is our Dynacon mooring spooler. It provides about the same pool as our TSC spoolers, but it holds about twice as much line. Next slide, please. Its most noteworthy feature is it's gigantic. So keep that in mind if you're going to use this thing to put an unusually large mooring in the water or something. It's going to take up pretty much the whole working deck. This does show one extra spare spool we have, which you don't have to use. But anyway, like I said, keep that in mind. Next slide, please. This is our Libus mooring capstan. It's another means of putting moorings into the water. This is primarily used for OOI work, but it's available for use by other folks as well. Next slide. And this is our only heavy duty winch. It's our Dynacon 664 traction winch system. On the upper left photo in the foreground is our traction unit. In the background is the spooling unit, which it looks like it's all one component, but it's actually two that bolt together. And then lower right-hand corner, it's an HPU. Upper right-hand corner, we have an instrumented block that goes with it. This is shown fitted with 681 cable, which is what we most often use it with. But it could also be fitted with 9/16 wire rope or 9/16. We used it recently to do coring with 9/16 synthetic line. We don't offer the line though, that has to be got from the wire pool. Next slide, please. And this is our marquee tensioning spooler. This is how we do all our spooling work for the most part. In the foreground, there's some traction sheaves that provides tension when you're pulling it on the ship. It tensions the wire. It's got a powered spool with a level wind on it, so we can spool it nicely onto a spool. In the background, on the upper left-hand side, there's a control van that has all the controls and whatnot in it. This breaks into 4 pieces, so we can stick this in ISO containers and ship them all anywhere you want in the world. And this can be used to apply up to 2,000 pounds tension on a cable or wire rope. So we can't use this to tension a larger line on a direct pull winch. However, we have other tools that can be used for that. Next slide, please. These are our line tensioners. The Pango tensioner in the middle is what you would need to tension a very large direct pull winch. And what these are, they're basically wheels with grooves in them that you wind the cable around and around, and then they have brakes. So when you pull against them with the cable on it, it tensions the cable. So we have these, the Pango for larger tension members, and the Blue and Gearhart tensioners for smaller ones. Next slide, please. Okay, in 2019, in addition to NSF and ONR, we had 6 other clients. Our winches were deployed on board Sally Ride, Robert Gordon Sproul, Oceanus, Sikuliak, Healy, Atlantis, and Kilamoana in support of 25 different projects. We also did spooling services for Sikuliak, Atlantis, and Ruben Lasker. Next slide. In 2020, we had a dramatic drop in our business because of the pandemic. And the biggest bummer of the year was we had shipped our largest winch system, the Dynacon 664 system, all the way to Fiji to be used on board the Thompson, but the cruise was canceled, and subsequently we had a really hard time getting it back, so that was a drag. Very expensive. Our clients for 2020 have been NSF, ONR, OOI, UCSD, and SAIC. The winches were deployed on board Oceanus, Thomas G. Thompson, Sikuliak, Sally Ride, Neil Armstrong, Robert Gordon Sproul, Ruben Lasker, and the Marcus Langseth in support of 15 projects. And we supplied spooling services to Sikuliak, Oceanus, Thomas G. Thompson, Sally Ride, and Roger Gravel. Next slide. Some engineering projects we accomplished. We negotiated the group purchase of 5 winches for ourselves, BIOS, and Hui. We accepted 4 of them. Hui accepted and tested their own. I made a new fire plan and hydraulic diagrams for the Sproul because we didn't have any. I arranged the purchase of a new level wind and overboarding block for RV Robert Gordon Sproul that would allow us to use a lower safety factor on the wire rope. Let's see, we designed and oversaw the construction of a new intersection for Roger Revell's squirt boom. When we took it apart in the shipyard during the midlife refit, it was in pretty bad shape. We needed a new one. We also specified and purchased a new set of sheave treads, which are coming soon, for Roger Revell and Sally Ride for their flagging blocks. The current tread is a hoop that has to be, you have to disassemble the entire flagging block, which is 2 stories up, in order to replace it. So it's just not feasible to replace it frequently. But I'm getting some built that are in parts. They're in halves. So you can get on a ladder or in a lift truck and put one designed for 9/16 on if you need to do coring, or swap it back over to 681 if you're going to use the 681 cable. It's feasible to do it in an afternoon. What else? Research requirements for portable cranes used on board vessels. This is worth mentioning. I was asked to look into, what exactly are the requirements that portable cranes need to meet. And I found something that was kind of surprising. It turns out that according to federal law, if you have a person that's not a member of the ship's crew that moves anything on board a ship, off of or onto a ship, that person's a longshoreman. And therefore the cranes that they use have to meet requirements in 29 CFR 1918 and 1919. If you have technicians on board the ship that move things around and they're not members of the ship's crew, these laws apply. If your technicians are using the ship's cranes that are registered as part of the cargo handling gear, then they're automatically covered. But if you have a portable crane, that's not the case. So if you have a portable crane and you need to know what kind of requirements you need to meet, then let me know. They're not unusual. I mean, they require proof testing, periodic testing, the keeping of logs and whatnot. It's kind of usual for equipment, especially cranes, but those requirements do exist. And I drafted an amendment, a very small one, to UNOLS RVSS Appendix A. Next slide, please. And that's all I've got. There's my contact information and that of my boss. If you need to find our website, just search NSF Winch Pool and we'll be the #1 hit, at least around here. And that's all I've got. Are there any questions?
I have a point. I just like to give kudos to both you and Eric for that group purchase that you did, getting 5 different winches and doing the engineering that needed to be done for different ships and different situations, and electric versus hydraulic, et cetera. It was complicated, and you guys pulled it off. So well done. And also, I want to mention that this was an example of the fleet's engineering expertise that you provided, and you are available for others in the fleet if they need this kind of work. So by all means, give Aaron and Eric a call. They've done a great job over there. That's all.
Thanks, Jim. And thanks a lot for your presentation, Aaron. Great work as always. We really appreciate all that you do. It's a behind the scenes job. It gets taken for granted, but there's a lot of really important work that's done. And with that, we want to shift over to Woods Hole and East Coast Winch Pool. Brian, guest.
All right, good afternoon. I kind of took the easy way out and did a pre-recorded presentation. So let's see how it goes.
Okay, so everyone can see, and just let me know if you can hear. I think we should be set.
Good afternoon. My name is Brian Guest, and I'm the manager of the UNOLS East Coast Winch Pool. I've been asked to speak to you today to give you some insight into who we are, what we do, the equipment that we have, and how to get in touch with us. The East Coast Winch Pool resides at the Woods Hole Oceanographic Institution in Woods Hole, Massachusetts, on beautiful Cape Cod. We have a staff of 3. Jamie Haley, he's our senior engineering assistant who oversees our shop and is in charge of maintaining all of our equipment. Josh Eaton is our lead engineer and has extensive experience in the electrical control systems, Appendix A and B requirements, winch applications, and more. And myself, Brian Guest, I handle logistics, budgeting, procurement. I lend a hand in the shop as needed. Before the winch pool, I spent 30 years as a seagoing technician, sailing with many of you in attendance today, deploying literally hundreds of moorings, deploying and recovering every type of gear imaginable, from towed bodies to gliders. We provide a wide array of equipment and services to various science groups in the UNOLS fleet. We provide winches, blocks, wire tensioning systems, and consulting services. We deal with vendors on the design and fabrication of new equipment, both for the pool and UNOLS marine departments when needed, and will provide setup of systems on board vessels, especially when the winch is utilizing a motion reference unit. Our inventory of winches range from ultralight duty systems like our CMAC 207 and up to our new Hobalt mooring winch that has a safe working tension of 10,000 pounds. In all, we offer 14 different winch systems. We also have the ability to wind some strength members onto not only our winches, but to the winches of our fleet with our tensioning systems. Our TSE system uses adjustable brakes to provide back tension through a set of bull wheels. The Pine Hill is an electro-hydraulic system capable of providing 3,000 pounds of tension. We also have a very old diesel system made by Lighthizer that can provide about 5,000 pounds of tension. Our Real Power system is a small winding cart that was modified by Josh with a very clever means of providing a constant tension when off-spooling light strength members. This eliminates the need to match speed with the winch when off-spooling and has been a real time saver for us. We do not loan out the Real Power winder cart. Our inventory also includes a small selection of blocks. These include Harken blocks suitable for 0.322, half-inch strength members, a couple of metering blocks, a few that are suitable for trace metal work, a 15,000 pound safe working tension 0.68 block, and a couple of others. Other miscellaneous equipment that we have are turntable winch mounts. These were designed by Jamie and Josh and fabricated at Hui. A pair of load cells, a quick check tensiometer that allows us to spot check tensions of a strength member while under load and in use. A 220 volt AC to 480 volt AC step-up transformer, also designed and fabricated in-house. And 2 MRUs that will interface with our McCartney winches as well as a couple of our Hobalt winches to provide active heave compensation. This slide shows a short video of Jamie demonstrating how easy it is to rotate a 5,000 pound winch onto one of our turntables. The winch can be locked into any position with an adjustability of about 2.5 degrees. This can be accomplished at sea and would allow one to use multiple overboarding points for a single winch or to mount the winch off the center line, which as we all know is prime real estate on vessels. We are currently designing a turntable for the West Coast winch pool to mount to one of their systems. A few years ago, Josh set up a website for the winch pool. This has proven to be extremely helpful, not only to us, but to our users as well. The address is winchpool.hui.edu. The site includes an equipment request form. This allows anyone to provide us with a good idea of the work they wish to accomplish. The vessel will take place on, weights of the gear and water, ports, and numerous other variables. This allows us to determine the best piece of equipment for the application, shipping dates, required strength members, etc. If a requester already has a particular piece of equipment in mind, they can check our schedule to see if it's available, and it also provides us with a graphical interface to keep track of our equipment. In our inventory section, you can pull up the specifications and details for any of our winches. Air weights, dimensions, safe working tension, drum diameters, and maximum capability documentation is available. And most importantly, it provides contact information for winch pool staff. We're on call 24/7 and have had calls at 3 a.m. from vessels at sea with questions or issues. While we never want to have an issue with one of our systems, we are happy to be here for you when need arises, even if the answer is, did you try turning it off and turning it on again? I want to thank you for your attention, and I would be happy to take any questions at this time. Thanks. Good afternoon.
Thanks, Brian. Well done. Appreciate it. Anybody have any questions for Brian? What's going on at the East Coast winch pool? The winch pools are just doing a great job, extremely valuable resource and enable a lot of great science happening at sea, a lot of creative solutions because there's never a simple challenge thrown at them. It seems like it's always a unique first time ever, and they're very adept at solving those problems. So I'm glad we were able to highlight them today, just like with the van pools. I don't see any questions, so we'll shift gears, and now we're going to, Dan Fernari from Woods Hole is going to talk about MISO and also the PFPE group. Dan, please take it away.
Thanks, Doug. Thanks, everyone. Appreciate the opportunity to talk with you a bit about what we've been doing with these two facilities at Hui. Alice has a couple of documents that she's going to put up on the screen that I will use as talking points. It's a little bit scattered, my fault, not her fault, because I'm trying in sort of real time to deal with some issues that we're having on both the Kilomoan and the Armstrong in terms of our operations that we're helping to support. With that bit of a preamble, I'll say, it's important to realize that both the MISO, multidisciplinary instrumentation in support of oceanography, and the PFPE, the Potential Fields Pool Equipment Facilities, are operated at Woods Hole Oceanographic, and they are within the SSSG, the Shipboard Scientific Services Group facility, which is managed, as you know, by David Fisichella. We came to that arrangement several years ago in 2018, and are now part of the SSSG facility support program that is run through Jim Hollick's program at NSF, and we're very grateful for that opportunity. So I'm going to give you some highlights of some of the operations and tasks that we've accomplished here over the past sort of year and a half. And I've got a couple of visuals to show you afterwards, and then I'll be happy to take questions. So the MISO facility really has focused largely on providing both imaging, deep sea imaging, and sensing capabilities for routine academic science throughout the UNOLS fleet, and also specifically we've been able to augment the National Deep Submergence Facility vehicles, Alvin and Jason, in their support of science programs as well. Over the last year and a half or so, we have provided multiple MISO cameras, some of them wired in, some of them powered and operated remotely as fixed focus cameras on both Alvin and Jason, as well as on separate lander vehicles, as well as sort of selfie sticks that have been put out on the seafloor to document operations. I didn't want to either bore you or take up a lot of time with a whole bunch of very high sort of resolution images and pictures. I'm happy to provide those to Alice. She can provide a link to the council and you can look through them. There are many of them. But suffice to say that these have been used to great advantage for Alvin and Jason science operations actually for many years now, but certainly over the last 18 months or so. In addition to this, both as part of my research and as part of the sort of objectives of the MISO facility, we have been working with the NDSF vehicle groups to enhance imaging capabilities and providing suggestions for improvements that the vehicles could consider, as well as continued development of deep sea imaging capabilities that can be used on a wide range of systems. And the last bullet point here is one that we've been working hard on over the last few years in terms of providing MISO imaging and sensing systems that can be used on MC800 multi-cores that allow you to both control the sort of tripping of the system by having a collar inserted on top of the spider to prevent pre-tripping, and as well as having depth and altitude in real time, images of both the collar and the top of the core tubes, and also seafloor images to make sure that you're landing in the appropriate spot. So that is a system that we've now tested on, I think about half a dozen of the UNOLS ships, some large and some smaller, on a variety of cables from 322 CTD cables, if the coring is shallower than about 1,000 meters, to coax cables and fiber optic cables. The system that's currently being used on the Kila Moana is using their 681 fiber optic cable with a converting electronics that was developed within MISO. I will also say that it's very important to recognize that a lot of this work that we do, especially with respect to the MC800s, has involved technical groups from many of the operating institutions, and their sort of collaboration and cooperation has been huge. And everybody is quite interested in seeing this capability further developed. As a result of COVID, if there is ever a silver lining in some of these sort of disasters, it has sort of forced me to be more diligent in terms of documentation, and all of the preparation that we did for that system that was used on the Kila Moana was done via remote training, setting up a system here at Hui, going through with several planned Zoom calls of several hours each to train the technicians that were going to be operating it, then packing it up, then shipping it out to Honolulu, then having them all put it back together. And miraculously it worked, and it has been working, although they've been having some issues both with hard bottoms as well as some of the batteries, but we are working through those currently. So I will show you a couple of pictures of that in a minute. And then finally, before Alice continues to scroll up, we've also been working hard on helping the community, providing both assistance and advice regarding dredging capabilities. And that's something that we've been doing given my sort of involvement with dredging over the past 2 or 3 decades. And writing up of some sort of best practices documents, if you will, that have helped both operators as well as investigators who are involved in dredging operations. So now you can scroll up a little bit if you can, thank you, or down. So let me talk for a minute about PFPE. So potential fields, basically gravity and magnetics. At Hui, we have, and as you may have sort of read in the blurb that we sent out in some of the pre-meeting notes that Alice provided, we've been doing this for nearly 2 decades at Woods Hole, providing gravimeter capability for the UNOLS fleet and support for technical support for the fleet. This is something that we have done with, I think, quite good success in working with the various operating institutions and the technical groups. We basically provide 24/7 support for the shipboard tech groups operating the BGM-3 gravimeters. This is, non-trivial in terms of making sure that we're addressing issues in real time. We have the both in-house help from our trained engineers, Steve Falutico, Stefano Suman, Tom Lanigan. And we also have outside help on a consulting basis from Randy Herr, who was one of Navoceano's premier gravity guys and is sort of the pinnacle of corporate knowledge regarding gravimeters, at least in the US. So we've been doing that quite successfully. And I think one of the things that I will point to is we have been extremely successful in working with the shipboard tech groups and the engineers on board the ship in regards to the importance of gravity ties and logging and communicating those reference data, both for themselves to have on record, as well as to R2R when they package up and send the TAR data to R2R, and also for our own internal use and maintaining records of tie locations and benchmarks. This is something that we're getting, more and more accustomed to doing. The technical groups are realizing that they have these systems, that they're getting used to the techniques for doing gravity ties and for doing the logging and for monitoring the sensors during the cruises. So it's something that I think we've made a lot of progress on in the last couple of years. And again, kudos to the operator to the operating groups who have taken this on. Some of the other things that we've had to deal with. So just as background, these gravimeters, some of them are 20, 30 years old. They represent technology which goes under the general heading of they don't make them like this anymore. And to some extent, maybe that's good because they can be a pain in the butt to deal with in terms of the technology and the electronics and whatnot. But we have been quite successful in keeping all of these gravimeters up and running. I will say, and I mentioned this later on in the bullets that you'll see down below, a big part of that has had to do with our cooperative research agreement with the National Geospatial Intelligence Agency, NGA, our colleagues there, where we've worked very closely with them over the last decade or so. And they provide us with some of their equipment, which is ex-NavOceano and now is under the auspices of NGA. And so we've worked hard to get as many of these systems into PFPE. We maintain them, we fix them, we recalibrate them, and we then get them out on the UNOLS vessels to use for geophysical data acquisition. Part and parcel with that is the need to periodically recalibrate the sensors. That happens every about 5 to 7 years. In some cases, it's relatively easy if a ship goes into a common port. And in other cases, like the Palmer, where they're usually down at the tip of South America, it's much more difficult. Again, one of the things that we've been able to do is take advantage of the issues related to COVID and the fact that the Palmer had to transit back up to the US this spring. We were able to swap out the BGM3 sensor 210 on the Palmer. Luckily, we had a tech pool technician, Emily Shimada, who used to be at Hui and is now at OSU. She was just superb and really provided great support for us. She had to make 2 trips down to Eureka to basically deal with getting the sensor swapped out and also a recalcitrant control power supply, which we had to get on an emergency basis from NGA. Anyway, lots of moving parts, but suffice to say, it all happened. The Palmer now has a newly recalibrated sensor in its BGM3 system, and I think is on its way south to resume operations, at least as far as I know. But we were able to do all of this, again, with Emily's significant help and OSU's allowing her to do this, and through the tech pool, which Brandy has also facilitated. So we also had to deal with swapping out the sensor on the Langseth. The old sensor, which was one of the oldest ones that we had, failed the recal and basically is sitting on a shelf at Lockheed Martin. We replaced it with one of the ones that we had. So Langseth did have a functional gravimeter for the season that it's just gone through. We have also provided a fair amount of both direct and remote assistance with the tech groups in helping them mob and demob gravimeters on and off ships. We've had to do this recently with the Healy and with the Revell and Atlantis and the Thompson, associated with midlife periods and shipyards and whatnot. Part of that effort meant that we updated our PFPE documentation that we provide to the shipboard techs, and that has proved very useful. Because of COVID and travel restrictions, we were not able to actually go and participate on site with some of that effort, but we were able to do it remotely through Zoom calls and whatnot, and through the updated documentation, it turns out that was quite successful. Let's see, just to keep going here. One of the things that we've also been doing is trying to, as best we can, to repair some of the older electronics that we've gotten from NGA, so that we've got adequate spares. This last sort of month and a half, where we had the problem with the control power supply on the Healy and had to sort of ship one out on an emergency basis, we actually stole that CPS from the system that we were going to put on the Armstrong for this testing that we're doing, and so we had to get a new one from NGA. Anyway, it's been a bit of a struggle to keep all of these systems alive because they're old, but they do provide a great capability, and they do collect excellent data. But one of the things that we've realized is we really need to find a substitute replacement for these gravimeters in the UNOLS fleet. And to that end, we were able to successfully make that case through a proposal to Jim Hollick's Oceanographic Instrumentation Program at NSF for a new marine gravimeter. Again, this is a marine gravimeter. This DGS is a company out in Colorado that's made numerous airborne and marine gravimeters over the last decade or so. In fact, their airborne meters are used frequently by the Lamont Group for aerograv studies down in Antarctica. We had worked with them closely and were able to acquire the meter from them. We took delivery of it in mid-July, and we have been putting it sort of through its paces and learning about it. And most recently, we did go ahead and put it on the Armstrong for a cruise that they were doing up off of Greenland and Iceland over the last month. So let me, Alice, if you don't mind, can you just turn to that Word document where I've got a couple of pictures that I can show? Okay, so yeah, so that I think that's the just scroll up to the top. Yep. The top. So this is yeah, no, all the way to the top to the first page. Yeah, there you go. Okay, so I just showed this because this was Emily's part of Emily's sort of swap out report for the Palmer. This is the ship to shore tie that she did. We have quite a well-established sort of protocol and documentation that we have set up to do this. And she did a superb job of it. And this is the kind of information that then gets fed into R2R and is documented with the shipboard data and metadata. So I just wanted to show that to sort of reinforce this notion that we're working hard to make sure that we've gotten all the appropriate ancillary data and metadata required for the geophysical data sets. Okay, so this is just the Armstrong leaving the dock about a month ago, a little less than a month ago, to head up north. On board were a bunch of folks, Bill Johns from the University of Miami and some folks from Scripps doing mooring work and CTD casts up off of Greenland and Iceland. If you go down to the next slide, that's Amy Semino, one of our lead techs for the Armstrong, and Tom Lanigan in the orange hat, carrying part of the BGM-3 system up onto the gangway. As you know, with the COVID restrictions, we basically brought stuff down to the dock and then stood back, and then they grabbed the instrumentation and put it on the ship and then installed it. Next slide shows, I think, yeah. So here we are. We're down in the transceiver room of the Armstrong. Here you're looking in the middle. You'll see the sensor and the platform that the BGM-3 sits on. It's underneath that gray rack in the middle. The BGM3 electronics is sitting in that rack to the left side of the image. And the ATM1 gravimeter is right next to it, less than a meter away on the starboard sort of bulkhead, if you will, of the transceiver room. So the gravimeters were all put side by side right there. Our intention was to try to run them at the same time to get some experience with how it compares, how the new DGS system compares with the BGM3. Next slide shows you just a couple of days of quick data. Actually, this is the track line that they made. They went up along the east side of Nova Scotia. The weather was bad, so they snuck up behind Newfoundland and then headed out to the site. So that track line basically shows you, for the most part, the data from this plot. The BGM3 data is in red. The satellite gravity, just for reference, is in gray underneath the red. And then we've offset the new DGS data above, but you can see the fidelity of the data is quite good. This has a cross-coupling function applied to it. We did, however, experience some noise in it, as you can see by some of those scattered sort of chicken tracks on in the blue lines. And in consultation with the folks at DGS, we realized that it could be that one of the sensor wires has come loose and was introducing some of this noise. So I think we've learned a lot from this first outing of it. We are planning to, the ship should be pulling in here in about a week. We're going to get that DGS sensor back to Colorado and have it inspected and repaired, and then hopefully get it back here to Hui. And I've already sort of started communications with the Hui Marine Ops and Sarah Fuller and David Fisichella and getting it out on the December Armstrong trip that's going down the East Coast so that we can do some additional testing. Our feeling is that it is really pretty important for us to get a good handle on the characteristics of this new gravimeter system, put it through its paces, and develop the sort of documentation that will need to go along with it to the other technical groups that will operate it hopefully on other UNOLS ships before we send it further afield. So I would say, right now we're talking about, very preliminary data. I would say it's been quite successful and quite encouraging in terms of the fidelity with which it is recording the same sort of signals as the BGM3. But we do identify some issues that we need to deal with, and so we're working through those. And we'll certainly have more update on this, by the end of the year in December. The last slide, I didn't mention this in my bullet points, but as part of this period where we have stuff ashore, we have taken the opportunity to refurbish the 2 magnetometer winches. These are small winches meant for the C-SPY 1 and C-SPY 2 systems that Hui PFPE has and has loaned out extensively to various operators. So we're doing this now. It's taken a couple of months, but we've had time because there are no immediate needs for the systems, but we've replaced all of the components for the support structure with stainless blocks, and refurbish the drums themselves. Anyway, this is all stuff that is all to the good and will help us in the future. So there's one winch that is done, another winch that is in progress. Okay, and the last couple of things that I wanted to show, and then I will stop because I think my time's up. But that the last couple of pictures, Alice, that you were going to show for me. So this is a picture of the MC800 multi-core that was set up at the new Marine Center at the University of Hawaii by their docks, with the MISO systems installed and almost nearly all wired up by the 2 technicians from OSU, Chris Fanchier and Drew Cole. Basically, we had about a half an hour Zoom session to go through things and just double check a few things. But, they basically wired up along with our instructions and all of the various labels. As you can see, there's a bunch of labels on all the cables, but everything was put together and it all works. And the next slide just shows them on the ship after they actually,
Oh.
no, that's the winch pool. That's all right.
Oops, sorry about that.
That's okay. That's all right. But the next slide just shows Drew and Chris on the back deck after they had actually done the mechanical and fiber optic termination to the Kilo Moana's 681 fiber cable, and it just shows them sort of standing right by it, and everything again was working. So I guess I'll probably stop there and see if anyone has questions, so I don't take up too much of your time. And again, one of the things that I will point out is Brian just earlier put me to shame in terms of the sort of web access to information. This is something that we've been working on and struggling with along with everything else, mostly just because of lack of time, but we realize it is important in order to properly communicate all of this information to the broad community of users. We will do better at that. We certainly have that capability at WHOI, and it's just a question of taking the time to do it. One of the things that I hope to be able to do is work with Masako Tominaga, who is also going to help take over some of the management responsibility for PFPE, and she and I can hopefully get some of this new information that we've developed up on the web and get the web sort of redesigned. We've done a good job in terms of, she's done a great job in terms of developing a new inventory for PFPE equipment. Now we need to make that more broadly accessible. Okay, I'll stop there. Thanks a lot.
Thank you.
Thanks, Dan. It was very informative. A lot of good info. You guys have been very busy, it seems like, despite COVID-19. So
Yeah.
thanks for all your efforts and creative solutions out there. Questions for Dan? Okay, well, it was very good. So thanks again for your time, Dan.
Thank you. Thanks, everyone.
With that, we're going to move on to Maureen Walczak at OSU. She's going to talk to us about the Marine Sediment Sampling Group.
Hi. While my slides are coming up, I want to mention, Dan, that the OSU techs were super complimentary of how you and Marshall documented everything for that setup. They said it went really, really well and everything was meticulously spelled out.
Thanks, Maureen. I appreciate it. And, you know, again, ditto for all of your folks. They were very patient with us, and we really appreciated this opportunity to work with them. And I think, you know, honestly, it's a big plus for all the technical groups to have this kind of documentation and have this kind of interaction, because I'm hopeful that we'll be able to put it on many of the other ships, and your group is going to be instrumental in operating some of this gear for other programs too. Yeah, we share that excitement. It seems like a big step. So for those of you who don't know me, this is my first UNOLS meeting. My name is Mo Walczak, and I'm a faculty member at Oregon State University in the College of Earth, Ocean, and Atmospheric Sciences. And I'm going to introduce you to the NSF coring facility. The official acronym is MarSSAM, for Marine Sediment Sampling. Can I have the next slide? So I'm going to start at the beginning. I think if coring has a reputation in UNOLS, it's probably that it's a pain in the butt to do. I think everybody knows that it's pretty involved. And so I think a good starting point for this exercise is to think about why we get the cores. And I hope I can share some of our excitement for mud. So what is a sediment core? Ideally, a sediment core is a minimally disturbed sample of the seafloor, extending from the sediment water interface, so that's the very bottom of the ocean, down to the sediment column, either a few centimeters, down to tens of meters. If you go much longer than that, then you're starting to look at more drill coring. So we handle everything from the mud down to between, maybe up to 50 meters beneath the surface of the sediment column. On the left here, there's a graphic. I guess, can anybody see my mouse? Probably not. This is Alice's mouse. So on the left-hand side, there's a graphic that shows a concept of a jumbo piston coring system. This happens to be one of our most popular coring systems because it gets quite long samples. But the important thing I want to show is that this coring system is lowered down to the bottom. That layer cake of brown and yellow is meant to be the subsea floor. There's a little trigger core weight that hits the bottom right next to that arthropod thing. When that trigger core weight hits the bottom, it lifts the weight on a trigger arm up the top of the core barrel, and then the big core free falls into the sediment at quite high speed. Getting a plug of that cake, the piston helps hold that plug in, and then that's brought back to the ship.
The graphic off to the right here is showing a section of a core, and you can see those little layers that are present in the sediment. So that's a really nice core. You can see that those layers are not mixed up. They're nice and clean. And that particular core did a really nice job of recovering a true representative sample of the subsea floor. The reality can be a lot more complicated. So depending on a variety of operational parameters, ranging from the needs of science. So some scientists don't really care if things are mixed up. Some need very pristine samples. The capabilities of the vessel, the shipboard handling systems, even the sea state, getting those pristine samples back can be a fairly complicated endeavor. And depending on the kind of science that needs to be done, getting those pristine samples can be crucial to the success of an expedition. Next slide, please. So why do science need these cores? I'm a paleoclimatologist, that's my background. But the basic broad reasons to get marine sediment samples kind of fall into two chunks. There are some people who want to know about Earth's past, and there are other people that want to know about the animals and the organisms that live in the sediment. So sediments in the ocean fall through the water column. They're deposited on the seafloor, kind of like pages in a book. They build up over time. As those sediments accumulate, they carry along with them geochemical and faunal information about the conditions of the water column, the presence of ice sheets on Earth, changes in ocean cycling and the carbon cycle, all kinds of things. They also can carry records of natural disasters like earthquakes and submarine landslides, and even large storm events produce a geologic signature that's preserved in these sediments. So that's one reason that scientists are quite excited to get these muds back. The other is that the seafloor, even though on a video camera it might look bereft, it's quite rich and resplendent with life. There are organisms that live in the seafloor extending down kilometers, basically through the entire sediment column. And those organisms, depending on what trophic level they're on, are either of direct economic importance to fisheries, or all the organisms in the ocean are super important for balancing our ecosystems and the biogeochemical cycling of nutrients, the chemical composition of our ocean, even the composition of our atmosphere are all tied to these organisms. Some biologists are also interested in looking at them for understanding the adaptations that allow them to live in these extreme environments. We had a researcher contact us recently who's interested in looking at echinoderms to understand the optical structures that they use to navigate in the deep sea where there's very little light. The bacteria that live in the sediment column, the chemosynthetic bacteria, may hold keys to the origin of life itself. So it's pretty exciting stuff that the marine biologists are doing with the sediments. Next slide, please. I'm not going to belabor this point because I know that the meeting is running over and we're all tired, but if you want more information on the kinds of scientific motivations for coring, I want to refer you to the Sea Change document, Decadal Survey of Ocean Sciences for 2015 to 2025. The contributors to this document included the Committee on Guidance for NSF on National Ocean Science Research Priorities, the Decadal Survey of Ocean Sciences, the Ocean Studies Board, Division on Earth and Life Sciences, and the National Research Council. Next slide, please. You can kind of click through these quickly. I don't want to go through all. There's 4 on this slide. So Alice, if you want to click through all 4. So these are 4 of the 8 science priority questions. The next slide is going to show the next 4. Every single one of these questions on these 2 slides will require samples of the marine sediments to answer them, whether it's to look at the changes in ecology, benthic biology, changes in past climate, origin of ocean basins. All of these things require sediment samples. All right, so next slide. So why does MarSSAM exist? We briefly mentioned that collecting sediment samples is kind of a pain in the butt. Again, those of you who have worked with us know that it's operationally pretty involved. And the reason that MarSSAM exists is to basically take some of that load off of your plate. So prior to 1992, the National Science Foundation put the responsibility for collection of sediment samples on individual investigators. They had to put into their proposals that they wanted to core. They had to fund the purchase of coring equipment or rent it if they didn't have it, and they had to provide the technical expertise to get those samples. However, as sort of a paradox, all of the samples that are collected by NSF after a moratorium, typically about 2 years, become available to the broader scientific community, where they're available in repositories for decades and used for decades. And so at the 1992 Future of Marine Geoscience meeting, there was a discussion of this issue, the enormous hurdles associated with recovering these samples versus like their long use and their wide community benefit. And it was decided that NSF would invest in a central facility to support all NSF supported PIs in coring. So that's the origin of the Oregon State University Coring Group as a facility. People have been coring here for longer than that. But now MarSSAM, which formerly was called NORCOR for a while, is a 28-year-old national facility located at Oregon State. Next slide, please. So what is our mandate? How can we help you? Our first mandate is to maintain, repair, and assist in the design of new coring equipment suitable for the UNOLS vessels. We're a sort of unique facility insofar as we provide scientific expertise in addition to technical expertise. So PIs, when they're writing proposals or planning coring programs, are welcome to and frequently do reach out to us for guidance on how to design their sampling program, what kinds of equipment to use, and we help them think through those questions. We provide logistical support, door-to-door service. We ship and stage all the coring gear. We send archival supplies, and then we also return all of the coring gear and the samples in refrigerated containers for delivery to an NSF repository of the PI's choice. We typically end up, just by happenstance, working with the Marine Geology Repository at Oregon State, but we work with others and we will get the mud safely to wherever the PI needs it. We also provide archival materials and a multi-sensor track for shipboard logging of sediment physical properties, which can be quite important for ensuring the recovery of good sample. We train in the operation of that MSCL, and we also train in the correct archival and labeling of samples. So I mentioned that these samples have a lifetime of decades in the US scientific community. And in order to ensure that they're curated well and able to endure that full life, we have to make sure that they're consistently labeled and all the correct metadata is collected such that somebody 20 years from now can go back through and know exactly where that mud came from and the circumstances surrounding its collection. And finally, last but not least, we provide shipboard support for the shipboard sampling operations. So that deployment of cores can range from the fairly simple. Most institutions that operate a UNOLS vessel have their own multi-core or a grab sampler. But we can provide technical support in deploying even the simplest, smallest coring devices. Our coring technicians do it all the time, and they have a lot of tricks up their sleeves that can sometimes make a difference. But most importantly, our technicians really exist to support jumbo piston coring operations. They have decades of experience between them, and they're very good at conducting those operations safely and successfully. Next slide, please. So who are MarSSAM? I mentioned that we're based at Oregon State University. So our sort of overarching pilot is our dean. But then beneath that, I'm the director of the facility. I have been taking over the reins from Mitch Lyle, who is retiring. And I have been helped quite a lot by Chris Goldfinger in that transition. He's helping me stick the landing. Obviously, I'm relatively early career. I've done a lot of coring, but these guys have seen everything under the sun. MarSSAM is also supported by an advisorial committee. These are just volunteers who spend their time helping us whenever needed, including the founder of our group, Nick Basias, Distinguished Professor Alan Mix, and Professor Joe Stoner, and then coring technician Chris Mosier and Pete Koch, who many of you may have sailed with over the year. I don't know if I'd call it a pleasure, but you likely have met those characters. The operational direction of our facility falls to my husband. He's featured in that photograph to the upper left there. If I'm the brains of the operation, he's the beauty. But he serves the important function of translating the science into technical expertise. He liaises with operators and with the ship's captain and crew on everything ranging from handling systems to deck layouts to on the science end, understanding what the scientist wants and why they want it. He oversees a group of 3 technicians, one of whom is full-time, 2 of whom are part-time. Chris Fancher, who is at University of Hawaii right now, working with the MISO system. Dale Hubbard and Ben Freiberg is our newest hire. These technicians, Dale has decades of experience like Paul. Chris and Ben are new. And it's our goal to try and disseminate this experience throughout the UNOLS technical pool. We also frequently sail special guest stars from the UNOLS tech pool. Right now, Drew Cole is sailing for us, and he sails for us quite frequently. If you have technicians that you want to gain experience in coring, including just for operating your own multi-coring system, talk to us. We do tech exchanges. Again, we do use the tech pool. We're trying to help share this information, spread this information, and increase the capability of all institutions. And so then at the managerial level, myself and Mitch and Chris, we liaise more with the program managers and the principal investigators. Paul does everything, talks to everyone, and then we always send a technician. Well, we don't always, but if you want a technician, we can always send a technician to help with the shipboard deployment of any of our coring devices. And if you want a jumbo piston corer, we will send a technician to help. Next slide, please. So our inventory is available to anybody who has NSF funding at no cost to them. Same thing with our technical support, very similar to the Winch pool. If you're not NSF funded, we can probably still help you. We just charge on a day rate that's determined by the average cost of the facility over the year. So the MarSSAM inventory is available on our website, but if you have any questions, please reach out and contact us. And we can also work with you depending on what you're trying to do, the size of your ship party, the available berths on your ship. We can send help if you want it, but we can also help train you if you don't, particularly on the smaller systems. Next slide, please. So our 2019-2020 shipboard activities, 2019 was a normal to busy normal year. We supported 7 major coring activities, including on the Ravel, the Oceanus, the Armstrong, the Thompson, and the Atlantis for a variety of different PIs. Operations ranged from slow coring and multi-coring up to jumbo piston coring, and we clocked a total of 164 NSF days. That's a normal to busy year for us. In 2020, obviously, like everybody else, our schedule's been decimated and constantly reorganized. Currently, we have 2 techs out on the Kilo Moana supporting multi-coring with PI Brian Haley. Turns out it's really good that we have them out there because delays to the schedule have meant that a bunch of the science party have had to leave. So our techs are basically out there with the PIs trying to get the job done. We did a shakedown cruise for some new MarSSAM equipment that I'll talk about shortly on the Oceanus for a few days. And then later this year, we will be supporting coring operations on the Shikuliak and likely at some level on the Sally ride. Next slide, please. Our equipment updates. So we have begun instrumenting corers to record tilt and acceleration data collected during the coring process that helps us know whether the barrel had a direct hit into the sediment column or went in at an angle, and also helps us understand the relative motion of the barrel and the piston. And the goal of this instrumentation is to help us improve the quality of sediment recovery and ultimately to decrease coring deformation. This picture on the bottom left here, quality 0 to quality 5 from Bourlet et al., shows what you can do with these systems when they're up and operating. We're at the point now where we're collecting the data. We have not gotten to the point of tuning, but hopefully that's going to be our next step next time we go out with the JPC system. And then we also, on the shakedown cruise, did the first that we're aware of side-by-side tests of the standard galvanized versus the ceramic coated core barrels that are used by the Antarctic program and by HUI. And we found that the ceramic coated barrels are significantly easier to handle, to couple and decouple on deck. So our coring techs were a big fan of that. And we have evidence that they modestly improve pull-out tensions. It was somewhat inconsistent by how much, even when you're coring the same site, all other parameters identical, but it does seem that if they do anything, they improve pull-out tension. We did, however, notice that of the tests that we were able to run, every set, the ceramic core had pull-out gaps that the galvanized core barrel did not. So those graphics off to the right there are CT scans of recovered core sections. That big black hole in the middle of the one on the right is what a gap looks like when the piston is moving much faster than the barrel. And so we are working now on trying to tune our piston retraction speeds to prevent that from happening, so we can have the advantages of the ceramic barrel while improving our recovery and having a high quality recovered sediment column. Okay, next slide, please. We also have worked the last year in improving the future of UNOLS coring, or contributing to the next step in coring. The regional class research vessels are coming online. These are going to present challenges to our standard system insofar as we won't be operating over the rail, we'll be operating over the stern. We do need that rail length in order to recover long samples. Again, many of those see change priorities, and what we're seeing in the scientific community is a demand for longer samples. So we have designed with Gloston a design specification document for a piston core deployment and recovery system. They're calling it the pachyderm, which I think is kind of cute. And so hopefully we'll start to see an actual design for what that might look like. We have some tentative ideas of what might work, but we're excited to see what the engineers come up with on that. But basically, it will go off the A-frame, pivot around to the side of the ship, and then pivot up along the rail. And then we also, at an earlier stage, which is exciting for us, recently contributed to the process and requirements list for supporting the collection of jumbo piston cores from the new Antarctic research vessel. So we're excited to see that come online. Next slide, please. So how do you request MarSSAM? When you're putting in your STRS request, there's major ancillary facilities. And under coring facility, there's a whole bunch of different boxes. In this one, I've checked OSU coring facility. It kind of doesn't matter which one you check. We're the only game in town. If you check coring, I'm going to be following up with you and your PIs to make sure that you have what you need. And if you don't have what you need, I'm going to try and make sure that you get that. And again, we can help with everything from archival materials to shipping to sending shipboard support. We do like to know what's happening as early as possible. We love to know what's coming down the pipeline. So if you hear a little bird on the wind saying that somebody might be planning a coring proposal, please encourage them to talk to us. We talk to PIs even at the proposal submission stage. We love to be involved. It helps us plan, and it helps us ensure that the designed coring program is going to be able to achieve the PI's goals. So again, there's no point that's too early. Next slide, please. So this is our last slide. I wanted to close by leaving my contact information up there. Our unofficial motto is what could possibly go wrong. And there's a link down there for a little video that was made by our department on why people collect sediment cores, if you want to have a look. It's got banjo music.
Okay. Well, thanks, Mo. Really appreciate that. That update, a lot of good information. I actually haven't seen it before, so it's good. I really appreciate it. Anybody have questions for MarSSAM and for Mo?
And Paul is
Mike
here
Prince
behind me.
Oh, hi, Paul. Mike Prince has a question. Mike, did you want to?
I know you're working on the new Antarctic vessel in the regional class, but do you have any comments on how the system modifications on Ryden Armstrong are working for you?
I might defer to Paul for that one.
I think that there's no reason to not request those ships to go coring with. I'm not a huge fan of using the crane to do a transfer around the fantail, but you know, they work. And the real beauty of those vessels right now is they're set up, Armstrong in particular, to use the synthetic HICO rope, which is a total game changer. It's a really, it makes such a huge difference, particularly in deep water. So that I think is really a biggest part of taking all this into the future, is going to synthetic strength members for deeper coring. Good.
Well, if you have any suggestions for improvement for handling, moving the core, please let Woods Hole or Scripps or me know that.
Thanks, Mike.
Thank you. Yeah.
Liz Sykes has a question.
Hi, Mo. Nice presentation. Hi, Paul. I would like, I think the elephant in the room is not just the pachyderm, but like, can you give us a little bit of an update on where we are with the line coring? Because I think that I agree with you, that's the future, and we need to know more.
So for those of you who haven't cored before, one of the issue with the 9/16 wire is that it has a breaking tension that is fairly low, and we can only pull on it so hard with the ship's handling systems before we're in violation of the AP-A, AP-B safety regulations. It used to be that you could pull on the wire until it broke, but now for a variety of reasonable reasons, We're not allowed to do that anymore, which has then meant that paradoxically, we're collecting shorter cores than we were capable of collecting 20 years ago. Maybe losing less gear. Well, actually, probably maybe losing more gear because we can't pull until it breaks. So this synthetic line, the advantage that it offers us is that it's neutrally buoyant, meaning that particularly for deeper coring, you're not fighting against the weight of the line. You're just pulling against the resistance of that core barrel in the mud, meaning that you can pull a lot harder to get a bigger sample, which is something that we all as scientists want to see happening. So we've been exploring options for retroactively making the global class vessels compatible with the synthetic line. Liz was the PI of our first trial cruise of that on the Thompson. So on the Thompson, and it went well, but we discovered that our cranes are not capable of handling the side loads involved, and so we actually need to do some work on the specifications of our crane and/or investigate a crutch that would make it possible for us to do a deck-mounted winch. The other option would be to actually try and spool synthetic onto the ships themselves, but we frequently encounter that because of the time and the effort involved in that, the ships don't particularly love it.
Obviously the issue would be, the time it takes to spool synthetic on to a ship's drum, taking off the 9/16 or the 680 or whatever, and the engineering behind doing that. This is one of those things where if you're thinking about, or you hear of a PI thinking about using one of your vessels, you need to get as much lead time as you can in, because if we want to say take Thompson or Ravel or Atlantis and we want to try and figure out a way to put synthetic on those ships, we have not actually done that yet on the ship's drums, and we would need a lot of lead time, and we'd need the winch pool, wire pool people to get involved with that. And excuse me, it can all be done. It's just time.
And we'd love to do it. So if you know of anybody who wants to try.
Can I ask a follow-up question? Yeah, because it's like you mentioned that you mentioned something about the regional class vessels that are coming on and coring through the A-frame. So is there a plan to have a line on those ships rather than wire?
Those ships, to the best of my knowledge, are coming all synthetic, but they're smaller ships. So the maximum length of core is going to be 50 feet or something like that, where Roger Ravel, Thomas Thompson has 100+ feet of rail available. So you're gaining the fact that they are going to come preloaded with the appropriate line, but they're just smaller.
Thanks, guys.
Thanks for that, Liz. Great questions. And I can echo. Yeah, you start planning way in advance of those cruises. The Thompson cruise.
Doug, Aaron. Oh, I'm sorry. Aaron had a question. Aaron Davis.
Go ahead, Aaron.
Yeah, it's not a question so much as a comment. We are drafting right now, the safety committee is drafting a change to Appendix A that will allow the use of a lower safety factor for systems that use both 681 and 9/16 wire rope. However, it's not going to be 1.5, a safety factor of 1.5. So I agree with Mr. and Mrs. Walzak that the thing to do is just get, for coring cruises, is just use a synthetic line. And it's quite expensive to change a line for one specific cruise. So if operators will try to put pressure, if they feel it's what they need to do, put pressure on the wire pool to buy more synthetic tension members and just have them installed on the ship beforehand, then I think that would help everybody.
Okay, we have to move on because we are running way over time, but it's a lot of great information. So we're going to finish up with John Collins talking about the Ocean Bottom Seismology Instrument Center, or OBSIC.
Okay, you ready for me, Alice?
Go for it.
All right. Okay. So I'm John Collins. I run OBSIC, which is the Ocean Bottom Seismometer Instrument Center. Right. We're funded by NSF OCE, Marine Geology and Geophysics, and our task is to provide seismic instrumentation to support research on the solid Earth, basically. So we make ocean bottom seismographs called OBSs available to NSF-sponsored investigators and possibly to other investigators with government, private, or industry funding. In particular, we've worked very closely with USGS here at Woods Hole. So OBSIC is housed at WHOI under a 5-year cooperative agreement that commenced in 2018. It is a successor to OBSIP, which many of you will be familiar with. OBSIP ran from basically 1999 until 2018. And OBSIP consisted of 3 institutions, WHOI, Scripps, and Lamont. And for the latter part of its existence was managed by an NSF EAR funded program called IRIS, Incorporated Research Institutions for Seismology. So next slide, please, Alice. So I just wanted to, many of you have seen OBSs, some have not. I've got a couple of slides here just to show you what they look like. The OBSs come in a variety of different flavors. Some are big and heavy, some are small. What you're seeing right here is one of the heavy OBSs. It's about 1,000 pounds in air, big syntactic foam flotation pack, aluminum pressure tubes holding electronics, a seismometer hooked onto the end of a deployment arm. Okay, that's the way it goes over the side, which you can see on the bottom right. Next slide, please. Sorry, keep going. Okay, so there's a picture of the same instrument sitting on the seafloor. That seismometer that was suspended in the deployment arm is now sitting on the seabed. That happens about some number of hours after the OBS is deployed. A galvanic link goes away and the OBS drops. This particular OBS had a problem. This is a picture from either Ropos or Jason, I can't quite remember which, of Oregon prior to recovery. Okay, next slide, please. So we also have some smaller OBSs, right? We use these primarily for active source work. This is, it could be a single ship experiment off the Langston, or it could be a 2-ship experiment where we deploy OBSs from a smaller vessel and then the Langston shoots to them. So on the right, you see a WHOI short period OBS. On the left, a Scripps short period OBS. Next slide, please. Again, some pictures of the short period OBSs on the seafloor on the left. This was in the days when the Alvin submersible could approach a glass-balled instrument. This was, I think, in the very early 2000s at the TAG hydrothermal mound. And on the right-hand side, you see a picture of a Scripps OBS, especially in top right, that was engulfed by a lava flow. That's a Jason picture provided by Dan Fernari. Next slide, please. Okay, who are we, right? There are 8 of us. Masako Tamanaga is the operations manager. That's her picture in the top, second from the left, and a bunch of engineers and technicians. Next slide, please. Okay, so we're based at WHOI. The lab is actually in the LOSOS building, which is what you see right here. We have a small part of that building in the bottom left-hand side, right? But we have a nice, obviously, working space. Next slide. The lab has about 3,700 square feet of really, really nice space, very well equipped, split into a mechanical lab, electronics lab, a sensor lab. We have a nice concrete slab to test our broadband seismometers. That's an integral part of what we have to do. Next slide, please. Okay, so what is in the OBSIC fleet, right? So we have short period OBSs. Those tend to be the small ones. We have the broadband OBSs, which tend to be very big. The broadband OBSs typically stay on the seafloor for a year. They almost all carry a big lithium battery pack, which has implications for all the shipboard operators. The short period OBSs, much of the time, carry alkaline packs. Because the OBSIC fleet, the NSF-owned OBSIC fleet, is not large enough to meet the needs of the community, we, OBSIC, issue subawards to Scripps and Lamont OBS groups for their equipment and their personnel. So, so for any OBSIC crews, we provide the instruments and the technicians to deploy the OBSs. Right. Next slide, please. Okay, where have we worked? This is an older slide, right? We've worked all over the world. We've worked in lakes, Yellowstone, Lake Malawi. We have instruments, from north of the Aleutians to this Drake Passage. And this is a reminder here. We are also tasked. This is the task of OBSIC, not the PI, to deliver all of our data in a very specific format to a data repository called the Data Management Center, which is part of that Incorporated Research Institutions for Seismology and NSF EAR funded facility. So that is a very important task for us as well. And here, as of the end of 2018, the combined on-bottom years for OBSs now was approaching 900 years. Next slide. Okay, I just wanted to show two slides, I think, on what we've been doing pre-COVID, right? Late last year, we completed an experiment to 5 degrees south on the East Pacific Rise off the Atlantis. This was a little bit unusual. This was because we had to do 30 wire-dropped OBSs in over 3,000 meters of water. If you look at the bottom right-hand side, those 30 OBSs were deployed in 3 little mini arrays, and the seismic goal there was to look at changes in earthquake-related changes in shear velocity generated by earthquakes very close by within the array. And one of the goals of this experiment was the PIs had predicted within a 2-year time frame that they would capture a large earthquake, and good for them. On March 22, they captured a magnitude 6 earthquake, right? So we are scheduled to pick up those instruments in January and redeploy them for another year. Okay, so next slide, please. And then we also had a recovery cruise in Brantsfield Strait, south of the Drake Passage. This was an experiment for Will Wilcock, UW. We had deployed them the year before on a Spanish ship, and we recovered them on a different Spanish ship in February. Next slide, please. Okay, so how do you go about requesting OBS instrumentation? For NSF-funded projects, all OBS costs are supported through the cooperative agreement between WHOI and NSF OCE, right? OBS costs for experiments supported by MG&G, the costs are not included in the PI's proposed budget, but we do provide an informational budget that the PI must attach to their proposal, similarly to the ship time request, and that lists the costs, the total cost of the experiment, the mobilization, shipping, batteries, cruise participation, return shipment. That lists the total costs in the PI's proposal. And there's a set of policies and procedures. There's the URL at the 3rd bullet point. And NSF has always said to me that PIs submitting to NSF programs other than MG&G need to contact their program officer to get information on how to include OBSIC costs in their proposals, because NSF has had some OBS proposals come in without an informational budget. Next slide, please. Okay, Alice, I think there is another, slide deck that I sent you, and I can switch over to what I have here on my screen.
Which slide deck are you talking? Would you like?
Take 3.
Oh, I don't have that one yet. So maybe why don't you start sharing that?
Okay.
I think you have the capability.
If you allow me to share the screen, I've got a slide up there.
You should be able to share.
there's a Gantt chart showing right now. So
participants are allowed to share their screen. So you need to click share
at the
screen
bottom.
in your Zoom controls.
okay.
Thanks, Brandy.
And then click again on the screen.
I just saw you. I just got your slides on email. Do you want me to share my screen? I'm happy to do it.
Yeah, that would be easier, I think. Okay.
Sure. We can do that.
So if you go down, keep on scrolling.
Oh, we're going too fast. There we go. There's your Gantt chart.
So Alice said to be okay, just to describe, you know, some of the issues we've had this year and what our schedule looks like next year. This was our 2020 schedule, which you see up there in the Gantt chart. And just like everybody else, you know, we've been severely impacted by COVID. We did manage to recover the Wilcock OBSs, but the return shipment took more than 3 months, and which also impacted our readiness for other cruises. The Pablo Canales Cascadia experiment was delayed till 2021, as was Lindsay Worthington's Queen Charlotte Fault active source and passive source experiment, delayed till 2021. We did just finish the Lizaraldi and Driana Islands active source experiment. That was also delayed by a week. And the Margaret Betcher Go Far 5 degrees south leg was supposed to go this month, but it's been delayed till January 2021. The Geraghty Pacific Array recovery, that's actually going to sail a couple of weeks early. Next slide, please. So I just want to talk about 2 experiments. The Worthington broadband OBS deployment, right? That was scheduled to sail in August. Newport to Ketchikan, deploying 28 broadband OBSs. We had 5 OBS techs, Hui and Lamont, quarantined in a hotel in Newport. That cruise was canceled on day 13 of the quarantine because of a positive COVID case amongst the crew of the Lancet. Our 4 techs flew home. We obviously had to ship our OBSs home. 1 tech remained in quarantine in order to sail on the ensuing Lizaraldi cruise. And she ended up in quarantine for 4 weeks, right? Which is a hard task. And the pictures just show you where we were supposed to deploy those OBSs. And it reminds me to say, one of the things that worries all OBS providers are shallow water OBS deployments. And in this particular case, a whole bunch of OBSs were scheduled to be deployed less than 100 meters water depth. And these OBSs can be readily trawled up, right? Next cruise. So this is the picture of, on the right-hand side, what Dan Lizaraldi and Donna Shillington were hoping to do this year. They were hoping to do that blue line, the strike OBS line, and 2 dip lines offshore the Aleutians. Okay, because of the positive COVID case in Newport, their cruise was delayed by about a week, right? That meant the techs were already in quarantine when the Worthington cruise was canceled. That meant the 4 techs, we had 4 techs in quarantine in Ketchikan. They were quarantined for a total of 3 weeks, right? And because of the cruise delay, because of OBS personnel requirements to actually sit in the federal jury duty, that cruise greatly reduced number of OBS deployments. Initially, Dan wanted to do 2 lines. 3 lines. He ended up with 2, and the second dip line was only instrumented about 50% density. Next slide, please. And this is my last slide. This is what we're looking at, OBSIC is looking at for next year, right? And it's a huge schedule, and it's obviously made much, much more challenging by the need to quarantine. I should say that some of these cruises required up to 5 techs, right? And those will be a combination of tech pool, combination of Scripps and Lamont and Hui technicians. But when you roll in quarantining before these cruises, it makes everything very, very demanding. So I think there are 10 cruises here between today and January of 2022. Clearly, not all of them can happen. So that's all I have. I'm happy to take any questions.
Thanks, John.
Thanks, John.
Yeah, it's been a big challenge for OBSIC to adapt to the virus and to keep supporting these big cruises. So thanks for the flexibility of you and your team. I know that's been a challenge for you and for the ship operators. Any questions for John? I don't see any. So thanks, everybody. Thanks to the presenters for the presentations. They were very informative today. We did run long, but I think there's a lot of good information and made a lot of people aware of. So thanks for doing so and hanging with us. We're up again next Monday. What are we talking about next Monday? We are
instrumentation and data facilities.
Yep. So more good information, a lot of make people aware, a lot of things that are happening behind the scenes that may not be so obvious. So thanks again, everybody, for your staying with us. And any last questions before we go? All right. Well, thanks.
We'll reveal the answer to the UNOLS trivia on the next meeting. I know you guys are all concerned about that.
And Mike Prince still is not allowed to answer. So. Okay. Thanks, everybody. Have a great evening.
Thanks, everybody.
Thank you, everybody.
Bye-bye.